Hi, I'm Miss Boom, and today we're going to look at the quotient rule. Now, if we have a function made out of two functions, f of x and g of x, then if they have derivatives, then we can find the derivative of all of it. And the formula for that is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator over the denominator squared. Now notice in your previous video with the product rule, we had something very similar, except it was a plus there, and obviously we didn't have the denominator. Now take out a piece of paper and try writing both formulas from memory and double check that they are correct. You should memorize both of them right now. Don't forget there's the other notation as well, where we can write u and v instead of f of x and g of x. So dy dx is equal to, so derive the numerator du dx times the denominator minus derive the denominator du dx times the numerator over the denominator squared. Let's do an example. So here we have 2x cubed plus 16 over 10 minus x squared. So the derivative of the top part is 2x cubed becomes 6x squared, and the derivative of the bottom part we have minus x squared becomes minus 2x. Now using the product rule, we have that times the bottom part, the minus that times the top part, but minus times minus 2x becomes plus 2x, and then the numerator 2x cubed plus 16. Now what goes at the bottom? It's the denominator squared. And so now we can expand. So 6 times 10 is 60x squared. 6 times minus x squared is minus 6x to the power 4. 2x times 2x cubed becomes 4x to the power 4. And then 2 times 16 is 32x. And again, you can simplify by collecting like terms and writing the number with the highest power first. Then we have x squared and the 32x over there. You can expand that, but you don't have to. Let's use a CAS calculator to check our answers. So we have, go to derive x, then in here we're going to do a fraction. At the top we have 2x to the power of 3 plus 16. And at the bottom we have 10 minus x squared. Then enter, and sure enough we have the same thing. Minus times minus is plus over there. Let's do another example, e to the x over e to the 2x plus 1. If you've forgotten how to derive exponentials, please revise that, but it was e to the f of x becomes f dash x times e to the x. So deriving the top part is easy, we have just e to the x. Deriving the bottom part means bringing 2 to the front, we have 2e to the 2x plus 1. Next, we write out our product rule. So we have that times the bottom part, and we have minus that times the top part. And the denominator is that squared. So now we have a look and we could start expanding, but first, is there anything else we can do? We notice that we have a common factor of e to the 2x plus 1. So there's 1 there, and 2 there. So we will take one common factor out of all of them. So we're left with just e to the x and minus 2 e to the x, and one of these at the bottom. Now e to the x minus 2 to e to the x is just minus e to the x, and then keeping the bottom there. And now we want to have positive powers. If I brought this to the top, so e to the x minus 2x, we're going to get negative power. So we're going to bring that e to the x to the bottom. So we have minus 1 at the top, and then bringing that to the bottom, we have 2x minus x is just x plus 1. Let's do another example, sin x over cos x. So again, deriving the top part, we have the derivative of sin x is just cos x. Derivative of the bottom part, cos x becomes negative sin x. Now applying the formula, we have that times that. Sorry, the derivative of the top times the denominator so cos x times cos x, and the derivative of the bottom times the top, so negative sine x times sine x, but we have a minus, the minus minus is a plus, and the bottom squared, so cos x squared. And now cos x squared, sorry, cos x times cos x is cos x squared, sine x times sine x is sine x squared, and we know cos x squared plus sine x squared is just equal to 1. So we have 1 over cos x squared, or in other words, sec squared x. And sine over cos is tan, and we know that the derivative of tan is that. Let's derive sine x squared over x. So sine x squared, using the chain rule, we have x squared becomes 2x and sine becomes cos of whatever's in there. And then x just becomes 1. So now the derivative of the whole thing is that times the bottom part, so x, and then that times the top part with a minus at the front over the denominator squared, x squared. So simplifying, we have 2x squared cos x squared minus sine x squared over x squared. One last example, x over 3 plus sine x. So the derivative of the top is 1. The derivative sine x is cos x. Remember, this line you do not have to write. You can go straight to the next line, which is deriving that. So you could have thought about writing 1 and then copying that down, minus the derivative of that. So you could have written cos x there straight away, times x over all of that squared. Now be very careful with this question. Cos x and x does not become cos x squared, but x should be written at the front like so. That's it from me today. Thank you for watching. I'll see you next time. Bye.